Hi there, this is Professor Monty. Now we're looking at how to solve rational inequalities using a sign chart. All right, so I've got the steps. They're mostly the same steps I have in my video on how to do it for a polynomial inequality. But the steps are we need to set it equal to 0. Then we need to factor, set each factor equal to 0, and find out what values of x make that 0. These are our critical values. We're going to put the critical values on a number line, check a test number between and outside each of the critical values to see if it makes each of those factors positive or negative. And then if it does make it, if we're looking for less than 0, we're looking for where we were getting all the negative intervals, greater than 0 for all the positive intervals. But with rational, there's one more step that if we have a less than or equal or a greater than or equal to, we still can't use as part of our answer whatever makes the denominator equal to 0, because it's undefined there. All right, so let's look at an example. And we're starting off, I've got this, it's already a 0 on one side. I'm going to do another video where it's not 0. I'll link it to the end of this video. But we've got a 0 there. These are already factored. If not, if we had to factor top or bottom or both, we do that. But we set each of those equal to 0. So I have x plus 4 equals 0. I have x minus 2 equals 0. Well, let's list it this way. That'll be a little bit nicer. So when I have x plus 4 equals 0, that's x is negative 4. And x minus 2, I add 2, I get x is 2. These are what we call my critical values. All right, and we're going to put those on the number line. Make sure you put them in the correct order. And then what I'm going to do up here is I'm going to put these factors, x plus 4 and x minus 2. I'm going to plug numbers into those to find out if they're positive or negative. What numbers do I plug in? Well, a number to the left of our furthest left critical value, say negative 5. A number in between, 0 is always nice, if you can, and it's in this interval. And then something greater than 2, well, maybe 3, 4, 5, 6, 10, whatever. It doesn't matter, just a number between 2 and infinity. And this could have been negative 3, it could have been positive 1, whatever. I usually use 0 when I can because it worked out nicely. All right, so these are our test numbers. And I'm going to test them up here. So I plug negative 5 in here. I get negative 5 plus 4 is negative 1. All I care about is the sign, not the number. Negative 5 minus 2 is negative 7. Plug in 0. This is why 0 is nice. 0 plus 4 is plus 4. 0 minus 2 is minus 2. And then I plug 3. 3 plus 4 is positive 7. 3 minus 2 is positive 1. What I'm looking for is x plus 4 divided by x minus 2. Well, in this interval, the top was negative, the bottom was negative, and negative divided by a negative is a positive. And over here, a positive divided by a negative is a negative, and a positive divided by a positive is a positive. I look up here, it says less than, so I'm looking for all the negatives. If it said greater than, I'd be looking for all the positives. Well, I've got a negative here as my only interval. So what makes this negative when I divide? Oh, it's any number between negative 4 and 2. Again, there's the equal sign, so I'm thinking I get to keep these numbers. And in fact, the negative 4 I get to keep. Because notice if I plug in negative 4 plus 4 is 0, divided by negative 6, 0 divided by 6 is equal to 0. That works, but I can't keep the 2. If I plug in 2, I get 6 divided by 0. That's not equal to 0. It's undefined. So even though I have the equal here, I can't keep the 2 because it doesn't make it equal to 0. It makes it undefined. So I have to put a parenthesis there. Be careful on that one. That trips up a lot of students, but it won't trip you up because you're going to be looking for it. Again, if you want to see what happens if that's not a 0 on that side, click on the link that you'll see. I'm going to link that video to this one so you can find it easily.